Hello everybody. Today we will start with the new chapter in physics standard 10th, that is machines. So first of all we need to understand the basic concept of a machine. Machine need not be only something which is very big and something which is like running with power and only when you plug in something and then it is going to work. No, they are all complex machines. What we are going to study in the 10 standard is not complex machines. We are going to see only simple machines. Now simple machines are the one which are just simple devices which can make easier to do work. So when you say that it is easier to do work, means what? Suppose I need to use a lot of strength to do a particular work. If I use a small machine like a spanner, so if I'm with my hand, if I'm tightening a nut or bolt, what will happen? I cannot tighten it too much. So to tighten it completely, or I'll have to put too much strength to tighten it completely. But if I use a simple spanner, I can just tighten it in a very easier manner. So you can see that first thing is what the machine does is makes your doing work easier. Okay. Secondly, it could that means the effort what will be required to do the work will be reduced. Secondly, what it could help you is by uh, increasing the speed of doing work, right? So when you use a simple machine, there is a chance that the same thing which you need to do, the effort would have been, the time which would have been required to complete that work would have been much higher. Now, because you are using a machine, the same work can be done at a higher speed. So the speed with which you can do the work increases. So that is another kind of machine. Or else it could be such that neither there is an increase in the effort or decrease in the effort, nor it is increase in the speed, but it is just allowing you to do a work at your convenient way of doing the or applying the force. Okay, so these are the three normal, very easiest way a machine is going to help you. One is either it will decrease the effort which is required to do the work. Secondly, it could increase the speed with which you can do the work. Or thirdly, it can just make doing the work convenient. Okay, so that three things are what is going to be seen in a typical machine. So let's see the chapter now. In our common experience, it is our common experience that it is easier to open a nut by the use of a wrench than to open it by hand. It is difficult to pull up a bucket of water directly from the well, but it becomes easier to pull it up with the use of a pulley. It is difficult to shift a heavy block by pushing it, but it is easier to shift it by using a crowbar. We can find many such examples in our daily life where the use of machines such as a wrench, pulley, crowbar, etc. makes the job easier. So wrench is nothing but a spanner. The pulley is a wheel through which there is a thread. The thread is going to be there. On one side it will be the bucket, and the other side will be you are pulling it up. So you are pulling it this way and not pulling it this way. Okay, when you are pulling it upwards, you need muscle power. You need muscle power to pull it. But when you are pulling it this way, the gravity is helping you. You can always hang on that thing and go up. So that's why it's easier to pull something down rather than pulling it upwards. And in case of a crowbar is a rod. It is just a rod which is going to be placed inside. So suppose I want to make this thing move, I can use this rod, I can put it over here and then I can shift it. So I can, using the crowbar, I can put that crowbar below this thing and then drift it or change its position from here to here. So you can see over here, I place it over here and then I am drifting it. So I am using it easier because applying the force over here will be easier. So crowbar helps you to lift the loads. So now let's see the functions and uses of simple machine. The various functions of machines are useful in the following four ways. So we can see the various functions of machines are useful for us in the following four ways. First, in lifting a heavy load by applying the less effort, that is a force multiplier. So the first category of machine is called as a force multiplier. So when I am using a machine, and due to the use of the machine, if the effort required or the force required for me to do their work reduces, then we can say the machine what I used was a force multiplier. Like for example, if I want to tighten a nut with my hand, and suppose the amount of work required by the amount of force required by me is like 100 Newton. Now the same thing if I'm using a spanner, and if by using a spanner instead of 100 Newton, even 25 Newton can do the same job, then what I'm doing is a force multiplier. I'm using the spanner which is multiplying the force which I am being applying 4 times. So that is how we see that a force multiplier will be reducing the amount of effort which needs to be put on to do the work. So we see the example over here. A jack is used to lift a car, a bar, a bar is used to lift the stone, a spade is used to turn the soil, pulleys are used to lift a heavy load, a wheelbarrow is used to carry a load. In all the examples, the effort is much less than the load, so the machine acts as a force multiplier. So so whenever the effort is much less than the load, we call them to be said to be as force multiplier. We will go in the detail of these particular things in the next section, but right now we are just understanding an example of force multiplier. The next is change the point of application of effort to a convenient point. So convenient point of application of force. So the force what we are applying, if we are just able to make the application of force in a convenient manner, then the machine is going to help you to just change the way you are going to apply the force. For example, over here, the rear wheel of the bicycle is rotated by applying the effort on the pedal attached to the tooth wheel, which is attached to the rear wheel with the help of chain. There's a point of application of the effort is changed from the pedal to the rear wheel. So you can see, understand this way. If the seat would have been backwards or your pedal would have been exactly on the wheel itself, so wheel है और wheel कोई pedal होता और हम लोग ऐसे करते, then it would have been difficult for us because the handle would be far off, and plus it will be not convenient. So what we are doing is that the wheel is back wheel, the rear wheel is connected to a chain, and the chain is connected to a pedal, and we are pedaling sitting aram se on that particular seat with the handle very close to you. So accordingly you are in a very convenient kind of a mode of application of force, because you are sitting aram se and you are pedaling, you are not on the wheel to give that particular problem of the effort. So that is how you can change the point of application of force to a convenient direction. Third is in changing the direction of effort to a convenient direction. So now see, effort needs to be done, but if I am giving a force in a convenient manner, if I am going to apply the force in the direction which is more convenient to me, like for example when you are drawing a water from the well. So when you are drawing the water from the well, if you have just the rope, and that you are putting the rope and the bucket inside the well and you are lifting it, I told you when you are lifting, what happens, you are doing what is called as a muscle power. You are using a muscle power. It may happen that if a small kid is there, he may not be able to withstand that much amount of load, and he may not be able to pull the water upwards in case the water, suppose let's say the bucket contains 10 liters of water, means 10 kg of water is there. Now this person himself is hardly 30 kgs और उसको अगर उठाने का रहेगा तो difficult होगा. So what is done is that you use a pulley. When you use a pulley, the rope from the bucket is going all the way around to the pulley. So it is this way that the bucket is over here, this is the bucket, and this is the rope. There is a pulley over here. For what happens is that the boy is standing over here and he is pulling the rope downwards. Now when he pulls the rope downwards, he need not have muscle power. He can even just do one thing. He go over, लटक भी गया ना, तो because उसका वजन ज़्यादा है, तो this will go up and he'll go down. So he can, वो लटक गया, नीचे बैठ गया, फिर से उसको पकड़ लिया, फिर से नीचे बैठा. So he may not require muscle power. His own body weight can be used to lift the water upwards. So here, what is important is that the direction of application of force. The direction of application of force, it will be much convenient if I am pulling it downwards rather than pulling it upwards. So if a bucket full of water is lifted up from the well without the use of pulley, effort has to be applied upwards. By using a single fixed pulley, it becomes possible to lift the bucket from the well by applying the effort in the downward direction instead of applying it in the upward direction. Thus, the person lifting the bucket up may also use his own weight as effort. Okay, he did not have muscle power, he can use his own weight as the effort to lift the bucket upwards. And finally, the fourth one, so this one was changing direction of application force. Change in direction of force or effort basically. And finally is change in speed. Okay, change in speed. So you need to gain in speed. So it's a gain in speed will be speed multiplier. So for obtaining a gain in speed, that is a greater movement of the load by a smaller movement of effort. Okay, you're moving a very small effort but applying a very small amount of force in the effort side, but a greater movement is available on the now this could be done when the pair of scissors is used to cut the cloth. Its blades move longer in the cloth while its handle move a little. You can see a scissor में क्या होता है, हम लोग अपना हाथ का movement कितना है, सिर्फ इतना, only this much. It's only this much, right? Whereas the blades are so big, so when you are cutting it, one movement over here, this small movement over here is going to cut this much amount of cloth at the same time. So you cut once, the movement is only this much, you cut here, it cuts this much, then it cuts another this much. So small movement over here gives you a large cutting action over here. So you can see that there is a gain in speed. Similarly, the blade of a knife moves longer by a small displacement of the handle. Here the effort is more than the load. So if I take a blade and I'm cutting it, so my movement is how much? You can see the movement in my hand. The movement I have the hand is so much. But when it cuts over here, it is going to cut this much part. So when I just cut it over here, it's the movement of my hand is very little, but the cut made by the blade or cut made by the knife on that particular piece of whatever it is going to be much bigger. So you can see that you are able to have a greater speed of doing the work if you are using a machine like this. So accordingly, hence we define machine as below. Okay, now because based on this we are defining machine. A machine is a device by which we can either overcome a large resistive force or load at some point or by applying a small force or effort. So that is the first point. That is a force multiplier. That is, it is which can either overcome a large resistive force, that's a load, at some point by applying a small force. That means a small force will be multiplied to give you a force multiplier. Effort. At a convenient point, okay, at a convenient point and in the desired direction, okay, and by which we can obtain gain in speed. So what are the three things? These four things combined give you the definition of a simple machine. So a machine is a device with which we can either overcome a large resistive force, which is called as a load, at some point by applying a small force. That small force, applied force is the effort. Okay, it's an effort at a convenient point and in a desired direction, or by because you cannot have this as well as this. It is either this or this. Either a particular machine will be a force multiplier or it will be a gain in speed. It cannot be gain in speed as well as force multiplier. A simple machine will not be like that. Okay, complex machine, yes, they do that thing, but simple machines, they will never be such that वो तेरा effort भी कम कर रहे हैं और speed भी increase कर रहे हैं. No, that is not possible. So that's why we say that the definition में ये 3 point, that is it is a force or it is that either overcomes a large resistive force when with the by applying some small effort or a small force at a convenient point in a desired direction, or okay, there is an or over there, or by which we can obtain a gain in speed. So or we can obtain a gain in speed. So this is the definition of the machine. So note, a machine cannot be used for force multiplier as well as a speed multiplier simultaneously. For a machine used for as a force multiplier, effort is less than the load, and while for a machine used for obtaining a gain in speed, effort will be greater than the load. So here we can understand it this way, that when it is a force multiplier at this particular kind, we will have that the effort is less than the load. But in case of a speed multiplier, so when it is a speed multiplier, the effort will be greater than the load. Okay, so effort will be more. Like example, let's take the example of the scissors itself. हम लोगों को काटने के लिए displacement तो बहुत छोटा है, but don't you need that strength? If I'm cutting some paper cut करने के लिए इतना strength लगता नहीं है, but scissors को करने के लिए you will need some strength. So that strength which is required when you are using a scissor or even while cutting, तो blade वगैरह है तो cutting के लिए क्या है, तो for that cutting you will require more amount of effort, but speed is going to be more. So that's about the definition of the machine. So we understand that machines are devices by which we can either overcome a large resistive force at a point by applying a small force at a convenient point and in the desired direction, or by which we can obtain a gain in speed. Okay, so this was the general we can say definition and the information about machines. Now we are going to see some very important terms which we are going to use in the chapter. So the first thing what you are going to use is load. So first thing is load. We defined machine as the one which can overcome a large resistive force. So that large resistive force is nothing but the load. So we say the resistive or opposite force to be overcome by a machine is called as the load. So the force which needs to be overcome by the machine is nothing but the load. So load is going to be always given as capital L. So that's load. The second one is the effort. Second one is the effort. Effort is always given as E. So we said over there that it is that particular small force which is applied on the machine. So that small force which is applied on the machine to overcome this load is nothing but the effort. So the force applied on the machine to overcome the load is called as effort. The force, that is a small force, or the force applied on the machine, the force applied on the machine to overcome the load is called as the effort. Accordingly, we have the first formula over here, that is the ratio of load upon effort, and that ratio of load upon effort is called as mechanical advantage. So mechanical advantage is MA is equals to load upon effort. So the ratio of load upon effort is called as mechanical advantage of a machine. So the ratio of the load to the effort is called as the mechanical advantage of the machine. Mechanical advantage MA is equals to load upon effort L upon E. So this is the explanation towards it. While using a machine to overcome a certain load, if the effort needed is less than the load, then the machine has a mechanical advantage greater than 1. So if the effort is less than the load, then the mechanical advantage is greater than 1. That means that particular machine. So if the machine is having the effort less than the load, then we can say it is a force multiplier. So that's why so if the greater than one, I'll read it again. While using a machine to overcome a certain load, if the effort needed is less than the load, the machine has the mechanical advantage greater than 1. While if it needs an effort greater than the load, it is a mechanical advantage less than 1. A machine has a mechanical advantage equal to 1 if the effort needed is equal to the load. A machine having the mechanical advantage greater than 1 acts as a force multiplier. So we have over here that if a machine has a mechanical advantage greater than 1, it is a force multiplier. Okay, if MA is less than 1, then it is going to be, so if this is going to be this way, that mechanical advantage is greater than 1, okay, then it is force multiplier. If it is less than 1, it is gain in speed. Okay, so if mechanical advantage, a machine having a mechanical advantage greater than 1 acts as a force multiplier, while a machine having a mechanical advantage less than 1 gives the gain in speed. The machine having the mechanical advantage equal to 1 is generally used for change in direction, as there is no gain in, so it will be, sorry, I removed that. So mechanical advantage, if is equals to 1, normally they are going to be used only for change in direction of application of force. Okay, so when I need only the change in direction of application of force, like for example when you're talking about the bucket full with water inside the well, तो वो क्या करना है, bucket का weight with the water is 10 kg, so the effort required will also be 10 kg. But why we are using the pulley? So that I don't need to pull it upwards, but I need to pull it downwards, so I can use my body weight instead of just using my muscle power. So in such cases, the mechanical advantage will be 1, right? So units of mechanical advantage, load is in Newton or kgf, effort is in Newton or kgf, kgf के cancel हो गया, इसलिए no unit. So mechanical advantage is a ratio of two similar quantities, that is forces, so it has no units. The next what we see is the fourth part, that is velocity ratio. So that is VR. Velocity ratio is given as VR. Velocity. What is velocity? The speed with which something is going to work. So here velocity ratio is the velocity of effort upon velocity of load. So if I am doing some work and if I see that the velocity with which I need to give the effort is something, and the velocity with, because of my velocity of effort, if my load is moving in a particular manner, so that is the velocity of the load. So we see that velocity ratio of the ratio of the velocity of the effort to the velocity of load is called as velocity ratio of the machine. That is, velocity ratio VR is velocity of the effort upon velocity of the load. Now if DL and DE are the distance moved in the same time. Now because we know that whenever we are moving the effort and moving the load, तो effort जितना move करेगा, जितने time के लिए move होगा, उतने के लिए ही load भी move होने वाला है. So till the time I am applying the effort, the load is going to move. When I stop applying the effort, the load will also stop. If I again start applying the effort, again the load will start moving. So the time for which the effort is applied and the time for which the load is moving, that is going to be the same. So when we see velocity, well, you know velocity is nothing but distance of the effort upon time, and this is distance by the load and time. Because time in both the cases is going to be the same, because जितना मैं effort डालूंगा उतना ही मुझे load में movement आने वाला है. It will never happen that I am going to move only once and it is going to go 10 अपने आप. Okay, so here not in simple machines. Yeah, if you talk about cycling, yeah, cycling में एक pedal मारा और आगे जा रहा है, that is different issue. This is multiple things. Okay, so let's not we confuse ourselves. That is a complex machine. वी आर टॉकिंग अबाउट सिंपल मशीन. स्पैनर को मैंने एक बार घुमाया तो क्या अपने आप घूमने लगेगा अपने आप? नहीं, इट विल नेवर हैपन दैट वे. मैंने अब बकेट में वो पुली के अंदर पानी को खींच रहा हूँ, एक बार खींचा तो अपने आप के ऊपर आने लगेगा? नहीं, इट इज नेवर गोइंग टू हैपन दैट वे. ओके, सो सिंपल मशीन्स में जितने टाइम के लिए मैंने एफर्ट डाला उतने ही टाइम के लिए मुझे लोड का मूवमेंट आएगा. दैट्स व्हाई द टाइम टेकन इन बोथ द केसेस इज गोइंग टू बी सेम. Accordingly, we have that velocity ratio can also be gathered by the equation dE upon dL. That is displacement of the effort upon displacement of the load, or the distance moved by the effort to the distance moved by the load. So that's why we get that the velocity of load is Vn is equal to dL upon t. Velocity of effort is VE upon dA upon t. So velocity ratio will be dE upon t upon dL upon t. That will be tt cancels. We get is dE upon dL. Thus, the velocity ratio is also defined as the ratio of the displacement of the effort to the displacement of the load. So velocity ratio is not only the velocity of effort to the velocity of the load, but also it is equal to the displacement of the effort to the displacement of the load. Now remember one thing, the velocity ratio is of any particular machine is decided the day, it is decided at the time of manufacturing that machine, that once it is made, the velocity ratio will be X value. That value will not change irrespective of friction or anything else. Velocity ratio of any machine always remains constant. It is the mechanical advantage which may change. Mechanical advantage may change because sometimes effort हमने डाला पर वो उसमें से बहुत सारा effort उसके machines के tightness में या तो उसमें problems था या rusting था तो उसको overcome करने में या friction में चला गया. So in case of the mechanical advantage, it may vary because it may happen that some of the effort is being lost, but in case of velocity ratio, the velocity ratio is never going to change. Whenever there is any particular machine, the machine वो machine में जो constant value जिस चीज का है, that is velocity ratio. Okay, a machine in which the displacement of the load is more. So now we understand this इसी तरह से as that one of mechanical advantage. We'll see how the velocity ratio का will change. So a machine in which the displacement of the load is more than the displacement of the effort will have a velocity less than 1, and such a machine gives a gain in speed. So if the displacement of the load is more than the displacement of the effort, तो obviously क्या हुआ, जैसे scissors displacement यहाँ पे इतना छोटा पर यहाँ पे बड़ा बड़ा काट रहा है, तो accordingly it will be less than 1. So if VR is less than 1, okay, if VR is less than 1, it is gain in speed. Okay, if VR is less than 1, it is gain in speed. Similarly, what would happen if the displacement of the load is less than the displacement of the effort? The machine acts as a force multiplier. So if the displacement of the load is less but the displacement of the effort is much more, then it is a force multiplier. So in case of this one, it will be a force multiplier. And finally, if VR is equals to 1, that means it is just change in direction. So it is change in direction of application of force. That should be the only reason. There would not be any reason when it is going to be equal to 1. So the velocity ratio of the machine is 1 if the displacement of the load is equal to the displacement of the effort. Such a machine generally changes the direction of effort. Since again the velocity ratio is also the ratio of two identical similar terms, that is nothing but meter per second upon meter per second, or distance upon distance meter per meter. So that's why they have no units. So this and this, both of them, they have no units. This has no units and this too has no units. So the velocity ratio and mechanical advantage has no units since they are ratios. Okay, we see the next one as point number 5, that is work input. The work done on a machine by the effort is called as the work input. So we know work is force into displacement. So accordingly, we know that the work done by the effort on the machine, okay, work done by the effort on the machine is the work input. That means what is the amount of force what you applied on the machine and what is the displacement of the effort which you have created on the machine is nothing but the work input. So work input is the work done by the effort on the machine. So accordingly, work done is equals to work done on the work input is the work done on the machine. Similarly, the next one would be work output. So work output, of course, output will be what? The one which is on the load. So that's why the work done by the machine on the load. So now we do an effort on the machine, but the machine does the effort on the machine does the work on the load. So whatever work the machine does on the load is called as the work output. So work output is work done on the machine by the load is work output. So work output is equal to work done on the load. And hence we have the efficiency. Efficiency of the machine is the ratio of work done on the load by the machine to the work done by on the machine by the effort. So we have over here the seventh one as efficiency. Efficiency is given by the letter eta. This is eta. It is normally in percentage. So efficiency over here. So efficiency is equals to work output upon work input. Okay. So work output upon work input is given as the efficiency of the machine. So efficiency of the machine is the ratio of the work done by the machine on the load to the work done by the effort on the machine. Or we can say work done by the ratio of the work done by the load on the load by the effort by the machine or work done on the machine by the effort. In other words, efficiency is the ratio of work output to the work input. So it is denoted by eta, and efficiency is work output upon work input. But efficiency is usually expressed in percentage. So that's why you are going to write it as work output upon work input into 100. So that will give you as efficiency in percentage. So efficiency percentage will be given as work output upon work input into 100%. So into 100% we'll write over here, we'll remove from here. Of course, that also work upon work, so no units. So it has no units since it is also a ratio of two similar quantities. Now you should note over here that when would it happen that work output and work input are not same? See, normally what we are saying is that मैंने यहाँ पे input डाला तो मुझे output मिलेगा, जितना मैं input डालूंगा उतना मुझे output मिलना चाहिए. But it is not true, because when I apply the input, maybe it happens that it may, like simple example, let's take the simple example of the pulley and the water only, drinking of the water. Suppose the pulley what I am using over here is completely rusted and jam packed, okay, वो jam है, तो हम लोग को पुली क्या करना पड़ेगा, बहुत जोर लगाना पड़ेगा, क्योंकि पुली को रोटेट होने के लिए फ्रिक्शन को ओवरकम करना पड़ेगा. And that's why when you're pulling it, the pulley doesn't move properly, and that's why you are not able to move it in a proper manner. So much of your effort is also going in moving the pulley over there. Or let's take the scissors. Scissors भी अगर समझो टाइट है, बराबर नहीं है, अगर प्रॉपर शार्प नहीं है, तो क्या होगा, बहुत दम लगाना पड़ेगा. तो automatically what will happen is the load the effort required will be more, or the work done on the effort will be more than the what we are getting on the load. So such a way we can say due to friction and due to the weight of the moving parts of the machine of a given design, its velocity ratio does not change, but its mechanical advantage decreases, so its efficiency decreases. So you can see over here that due to any friction, or I told you earlier also, due to any friction or any kind of losses which would be taking place in my effort, the velocity ratio will never change. Velocity ratio does not change, but the mechanical advantage decreases, so its efficiency also decreases. So mechanical advantage decreases and efficiency also decreases when there is friction or there is a load is being, some kind of a thing is being added to the load, so then in such a case it will be decreasing the efficiency. So now we move on to the next part, that is principle of machine. Okay, but that we'll do in the next video.